Okay, so I want to talk about the difference between the shapes of the graph. So when we graph speed, we graph them in time versus distance. Okay, so time is here and distance is here. So time is going to be your x and distance is going to be your y. So we're going to say that the distance that you cover depends on the time. Okay, so the first question that we're going to talk about is what is the difference between the shape of the graph for a slow walker and for a fast walker? So you think about it, if we have, two graphs, the slow walker would cover less distance in the same amount of time. Okay, so that means this measurement would be less. So the slow walker might look something like that. Whereas a fast walker or a jogger might look something like this because they cover more distance in a shorter amount of time. Okay, so that would be kind of the difference. And then we would say, the steeper the slope of this, right, the more distance they're covering in less amount of time, right? So that's really how we talk about this, the shape of the graphs. Okay, now the next question that we want to talk about is what would it look like if a walker was not covering any distance at all? Okay, what exactly would that look like? Well, it turns out time would keep going, but distance wouldn't change. So that would actually look like this. Okay, and that would indicate that someone is standing still. Okay, so perhaps we have a situation where a walker or runner would cover a certain distance to here and then would stop and stand still. And so this shape would suggest that we were moving to a certain amount of time and then at some point we stood still. And then of course if they started to move again, then it would go like this. They would be moving again. So the flat part of the line would be the time where no additional distance was covered. Okay, so that's how we talk about the shapes of the graph. But the next question we have to ask ourselves is exactly what's the difference between the velocity graphs and the time distance graphs. Well, we know that velocity is a vector, so it talks about direction, whereas speed, a basic time distance speed graph, doesn't have any direction. It just talks about the amount of distance that's covered in a certain amount of time. So speed graphs cannot be negative, right? Where this would actually have a negative slope. Well, velocity graphs can be negative, okay? It doesn't necessarily mean that you're slowing down because that would have to do with this acceleration. It has to do with the direction. So for this particular graph right here, we're talking about positive velocity, okay? So positive velocity. So this person is moving in a forward direction, okay? Whereas this person right here seems to actually have an identical slope or identical average speed. They're moving in a negative direction. So we would say that this person is moving forward. So this person is maybe starting at this starting line and going this way, whereas this person is starting at the starting line and they're moving in this direction. And it appears, based on the similar slopes, that they're actually doing that at the same speed, but they are moving in different directions. So we do have to pay attention when we're looking at our graphs to know if we're looking at a speed graph or a velocity graph. Remember that speed graphs can only be positive because they do not have any consideration for direction. And a velocity graph, because it is a vector, not a scalar measurement, can indeed be negative, and it means that you're moving in a negative direction, right, south or west, not in a negative manner, not losing any speed at all.